In this video, we are starting section 6.3 on the unit circle. Our goals are going to be to convert angles from degrees to radians and vice versa, to evaluate trig functions using something called a unit circle, and to prove one of the big trig identities, sine squared theta plus cosine squared theta equals 1. All right, so what is a radian? So if I think about a full circle, we've typically measured angles in full circles with degrees, and a full circle has 360 degrees. But why do we use that number 360, like as opposed to like 100 degrees or some other value? And the answer is that, well, 360, that number is divisible, it's evenly divisible by a lot of numbers. A lot of numbers evenly divide 360. And that's nice for breaking it up into a bunch of different sized pieces. Okay, but that number itself is kind of arbitrary. There's nothing special, there's nothing directly relating 360 to that circle. So my next question is then, is there a way to measure angles that is more directly related to the properties of a circle? And the answer is yes. Yes, there is. And that's going to take us to this definition. All right, so what is this new way? I'm going to give a definition, and it says this is called a radian. So a radian is going to be the angle, theta, whose corresponding arc length is the radius. So what that means is, in this picture of the circle, this angle here at the center of my circle, I call it 1 radian. If the arc of the circle, that's this length on the edge of the circle that it cuts off, if the length of that arc is r, if it's the same thing as the radius. Okay, so that radian angle is directly related to the radius of the circle, the size of the radius. So a natural question is, well, how many radians then are there going to be in a full circle? So if I were to, I could measure out a few more of these radian pieces to estimate it, but so if I said this is also 1 radian, well, that's going to cut off an arc whose length is the radius. If I measured 1 more radian, it would take me almost to the halfway point of the circle, not quite, but almost to the halfway point of the circle. And this would also measure an arc of length r. And I could keep going like this. But what I'll need to know to figure out how many radians there are in a full circle is, well, what is the length all the way around the full circle? What is that arc length? So we call that the circumference. The circumference of the circle is 2 pi r. So to figure out how many radians there are in a full circle, I'll set up a proportion. So when the arc length is r, that corresponds to an angle of 1 radian. So that should match a fraction where the numerator is the entire circumference, and the denominator then is going to be the radians in a full circle. The radians in a full circle. Okay, so the circumference, we just said what that was. That's 2 pi r. That is 2 pi r. Okay, so the left-hand side, r over 1, well, that's just r. And the right-hand side is 2 pi r over some mystery angle, but I need this fraction to simplify to r. So for that to happen, that denominator's got to be 2 pi. It's got to be 2 pi radians. Okay, so I'm going to highlight this. So the number of radians in a full circle is 2 pi. There are 2 pi radians in a full circle. And when we say pi, we mean our same about 3.14, that number. So multiplying that by 2, that is about 6.28. There are about 6.28 radians in a full circle. Okay. So when we first see that, we might be like, why would we use like a non-integer value to measure like the number of, however many there are of these in a full circle. But we'll get to that. There's a big reason why radians are nice, besides the fact that they are directly related to the radius of the circle. So some key facts first. Going a full circle around 360 degrees, well, that's 2 pi radians. So if I were to go a half a circle, 180 degrees, that would be pi radians. Okay, so let's do some conversions. So let's say I wanted to convert 210 degrees to radians. So when I do a unit conversion, I multiply by a fraction, where the top and the bottom got to be the same, but to cancel degrees, I need degrees on the bottom. So I'll use the fact that 180 degrees is the same as pi radians, because now those degrees will cancel. And I can also divide the 180 and the 210 both by 30 and be left with 7 and 6. So multiplying now, I'll get 7 pi over 6, and the units that are left are radians. So 210 degrees is 7 pi over 6 radians. So one thing to note, we usually don't write our units in radians. So like normally we would see this simply written as just 7 pi over 6. And when I see no units there, it's implied that the units are in radians. All right, let's do another one. Let's say I want to convert 3 pi over 4 radians to degrees. Okay, so I got to multiply this now by radians on the bottom. So pi radians is the same thing as 180 degrees. So my radians will cancel, and the pi will cancel. So this pi will cancel that pi. And I could also divide both the 180 and the 4 by 4. So I'll be left with the 1 down here, and then 180 divided by 4, that is 45. So we got 3 times 45, that is 135. And we are left with degrees as the units. Okay, awesome. All right, so the big reason for radians has to do with calculus. In calculus, you learn how to take what's called the derivative of a function. That's one of the big things in calculus. And the derivatives of trig functions are really simple when you use radians, but if you use degrees, the derivative formulas are a lot more complicated. Okay, that's something that you'll see likely in your next math course.